Ladies and gentlemen, this is Miss Humbert here. Today we're going to be doing Unit 8, Notes 4, so we're talking about rationalizing the denominator. So what is rationalizing the denominator, and why do we have to do that? Well, if you remember when we talked about a simplified form of a radical expression, there were no perfect squares underneath that radical. That also meant that there were no fractions underneath that radical and no radicals in the denominator. So we're going to go ahead and we're going to kind of work so that there are no radicals in the denominator. So for example, we're going to have to use this quotient property, this idea that if you take the square root of a divided by b, we can split that up into being the square root of a divided by the square root of b. So let's go ahead and let's put that into practice. Well, first of all, I can reduce this fraction underneath the radical. Both 15 and 12 are divisible by 3, and then I have 5 and 4. So I have 5/4 left underneath the radical when I divide 15 divided by 3 and 12 divided by 3. So now I'm going to go ahead and I'm going to use that quotient property. I'm going to do this divided by 5, and then this is going to be 4. So then what I can notice is that I can take the square root of 4. That's one of my perfect squares. So I end up getting the square root of 5 divided by 2. So that worked out nicely for me because I can't have a radical in the denominator. So that's my final answer, and my radical doesn't have a fraction underneath. So that is fully simplified. Same thing is going to hold for number 2. When you have 21 divided by 27, we can reduce that fraction. 21 and 27 are both divisible by 3. So then I end up getting 7/9. Again, I'm going to go ahead and I'm going to apply that quotient property. So I'm going to split it up to be the square root of 7 divided by the square root of 9. Well, I know what the square root of 9 is, and that's going to be 3. So I can keep that square root of 7 the same on the top, and the square root of 9 is going to become 3. So then here I end up having the square root of 7 divided by 3 as my final answer. So that works out because there's no radicals in the denominator and no fractions underneath. So what is this rationalizing the denominator that I'm talking about? So rationalizing the denominator is when you do have a radical left in the denominator, we have to go through a process called rationalizing the denominator. And so to do that, first thing you want to do is just to simplify the fraction or the radical expression as much as you can. Then you're going to take a look at whatever radical is left on the bottom, and you're going to multiply the top and the bottom of the fraction by that radical. Now remember, if you multiply by the same number over itself, that's equal to 1. So we're really not changing the value of the problem here. And then after that, you're going to go ahead and you are going to simplify. So let's take a look at an example of that. So I have the square root of 1/3. So the first thing I'm going to do is I'm going to split it up. Then I'm going to see, okay, can I simplify 1 or 3 at all? And no, I can't. So I have the square root of 3 in the bottom, and that's not something I can have. So what I need to do is multiply by the square root of 3 over the square root of 3. So then when I do that, I'm going to take 1 times 3, and that's going to be the square root of 3. Then when I multiply the square root of 3 times the square root of 3, okay, whenever you take something underneath the radical, that's going to end up being 3 times 3. Well, what you notice is you have a pair underneath the radical that you can go ahead and take out. Remember, when everything ends up being a pair underneath the radical, then the radical goes away altogether. So I still have that square root of 3 on top, but when I take the square root of 3 times 3, that's just going to end up being 3. So notice by multiplying by the square root of 3 over the square root of 3, I've gotten rid of that radical in the denominator altogether. Now some students get tripped up and they try and divide these guys out right here. You can't do that. If one's underneath the radical and one isn't, they can't relate. Okay? So let's take a look now at this next one. So I have square root of 12 and square root of 10. So I'm going to split that up into two radicals. So I'm going to make that square root of 12 and square root of 10. So I see that I have a radical on the bottom. There's nothing I can do with that radical on the bottom except for rationalize the denominator. So I'm going to have the square root of 10 over the square root of 10. So when you multiply the square root of 120 times the square root of 10, you're going to multiply 12 times 10, and that's going to give you 120. Then underneath the radical, I'm going to have the square root of 10 times 10. So underneath the radical, I have two pairs of 10s. So I'm going to still have the square root of 120 on top, and then I'm just going to have my 10 on the bottom. Now before I can say I'm completely done, I need to check that 120 can't be simplified any further. So let's take a look at 120 as a radical. We can break that down to be 12 and 10. 10 we can break down to 5 and 2. 12 we can break down to 4 and 3 and 2 and 2. So it looks like out of that radical I can take out a pair of 2's. So that is what I'm going to do. I'm going to take out a pair of 2's. So then I end up getting 2 times the square root of 3 times 5 times 2, which is 30, divided by 10. So now what I notice is this 2 and this 10 are both on the outside of the radical, which means I can reduce that fraction. 2 divided by 10 ends up being the same as 1/5. So that's the square root of 30 divided by 5 when you reduce that fraction. Next, let's take a look at number 5. Number 5 is going to be the same, so I'm going to split it up to be the square root of 10 divided by the square root of 3. And then I'm going to multiply by the square root of 3 over the square root of 3. So then I end up getting 10 times 3, which is 30, and then underneath my radical, I get 3 times 3, so those two are going to come out out of the radical. So I get the square root of 30, and since I have a pair of 3's, I'm just going to have 3 on the bottom. Now I'm smart enough to know that the square root of 30 doesn't have any pairs, so that can't be simplified any further. So now I'm going to take a look at number 6, and I actually don't even have to rationalize the denominator on number 6. So when you split it up into two radicals, you end up getting the square root of 6 over the square root of 9. Well, the square root of 9 is a whole number. I know that. So I'm actually going to take the square root. So I get the square root of 6, divided by the square root of 9, which is 3. So my answer then is just the square root of 6 divided by 3, because when I simplified it, that square root of 9, I didn't even end up having to reduce that fraction. Now let's take a look at number 7. There's a couple different ways you can do number 7. I noticed that 27 can be simplified to start off with. If you don't want to simplify to start off with, you don't have to. It'll still work, but sometimes I like to simplify it early so I have smaller numbers to deal with. So I'm going to go ahead and I am going to simplify the square root of 27. So when I simplify the square root of 27, I end up getting 9 and 3. And 9 I can break down to 3 and 3. So here's a pair of 3. So the square root of 27 is really the same as 3 square root of 3. And that's being divided by the square root of 15. So again, I can't have that square root in the denominator. So what I'm going to do is I'm going to multiply each of these by the square root of 15. So then when I multiply it, this 3 is being multiplied on the outside by itself. So I'm going to leave that as is. And then I can multiply 3 times 15 together to get the square root of 45. Then on the bottom, I'm going to have the square root of 15 times 15. So here I'm going to end up having some pairs that I can take out. Before I go any further, I know that I can break down the square root of 45, because I can break that down into 9 and 3, or 5, I'm sorry. And 9 breaks down to 3 and 3, so I can take out a pair of 3's. So I have this original 3 on the outside, and then I'm going to take out a pair of 3's from the 45, which leaves me with a 5 underneath the radical. Then when I have the square root of 15 times 15, that's just going to end up being 15. So 3 times 3 is 9, so I have 9 square root of 5 divided by 15. So on the outside, I have this 9 over 15. So I can actually reduce that fraction. 9 and 15 are both divisible by 3. So I get 3 square root of 5, and 15 divided by 5 is 5. So I get 3 square root of 5 divided by 5 for my final answer for number 7. So taking a look at number 8, I can again simplify the square root of 12 to start off with. So 12 I can break down to 4 and 3, and 4 I can break down to 2 and 2. So my square root of 5 is going to stay that way on top, but on the bottom for 12 I can take 2 times the square root of 3. Now here's where simplifying it out in advance is helpful. So when I go to rationalize the denominator, I only have to rationalize this square root of 3. So all I have to multiply by is the square root of 3 over itself. That's it. I don't have to worry about that 2 because that 2 is already rational. I don't have to worry about that one. So then that's going to be 5 times 3, which is 15, divided by 2 times the square root of 3 times 3. Well, I can take out a pair of 3's. So that's going to be equal to the square root of 15 divided by 2 times 3. That's going to be equal to the square root of 15 divided by 6. Now the square root of 15 cannot be simplified down anymore, and we can't reduce the fraction because one is underneath the radical and the other is not. So let's take a look now at number 9. So for number 9, I'm going to split up. 3 and 21 cannot be simplified down anymore. So I'm going to end up getting the square root of 3 divided by the square root of 21. So I'm going to have to rationalize the entirety of the square root of 21. So when I multiply underneath the radical, 3 times the square root of 21 ends up giving me 63. Then I'm going to have the square root of 21 times 21. So again, I'm going to have that pair of 21s down in the bottom. So I know the denominator of my new fraction will be 21. And now I want to take a look at breaking down 63. So when I break down 63, I'm going to have 9 and, not 9 and 3, that would be 27, 9 and 7. And then 9 breaks down to 3 and 3. So then I could take out a pair of 3's out of that 63. So I'm going to have that pair of 3's that comes out, and left underneath the radical is 7. So what I notice on the outside is that we have 3 and 21 on the outside. Both 3 and 21 are divisible by 3. So I can go ahead and I can reduce that fraction, which is going to reduce to 1 over 7. Since it's a 1, I don't need to write that on the outside of the radical. You can if you want to, but you don't have to. And then our denominator is just going to be 7. So we end up getting the square root of 7 divided by 7 for number 9. Taking a look at number 10, I want to split and I want to do the square root of 4 divided by the square root of 10. Well, frankly, I know the square root of 4 is 2. So I'm going to have 2 over the square root of 10. Well, that didn't help me with my denominator. My denominator is still irrational, so I'm going to have to rationalize the denominator. And I'm going to do the square root of 10 over the square root of 10. So then I'm going to get 2 square root of 10 divided by the square root of 10 times 10. So I have a pair of 10's underneath. So I have 2 square root of 10 divided by, when I take those pair out, that's just going to be 10. So the last thing I need to do is kind of reduce this fraction. 2 divided by 10 can be reduced, and they're both divisible by 2. So that's going to end up being 1/5. Again, I don't need to write that 1 on top because it's just a coefficient of 1 to my square root of 10. Then 10 divided by 2 on the bottom is 5. All right, 3 more left. Let's take a look at number 11 and 12. So now we're doing it with some variables. So I can't split up the square root of 3, but I can split up 8x cubed. So 8 I can break down to 4 and 2, and then I can break 4 down to 2 and 2. So underneath that radical, I end up having 2 times 2 times 2, and then 1, 2, 3 x's. So now I'm going to go ahead and I'm going to circle my pairs. I have a pair of 2's here, and I have a pair of x's there. So now I'm going to go ahead and I'm going to take out that pair of 2's, and I'm going to take out my pair of x's. Then left underneath the radical is 2x. So then that's what my simplified version is going to be. So I'm going to have the square root of 3 divided by 2x times the square root of 2x. So now how can I fix that square root of 2x? I need to rationalize that. And notice that I'm only rationalizing the square root of 2x. So then when I multiply that out, I'm taking 3 times 2x, which is the square root of 6x. Then on the bottom, I have 2x. And underneath the radical, I have 2x times 2x. So really, I have a pair of both. So those are going to come out from underneath the radical. So I'm going to have the square root of 6x divided by 2x times 2x. Well, I can't simplify the square root of 6x anymore, so that's going to stay the same. When I multiply 2x times 2x, 2 times 2 is 4. When you take and you multiply x to the first times x to the first, that's going to give you x squared. So I end up getting the square root of 6x divided by 4x squared. Okay? All right, so let's take a look now at number 12. So for number 12, what we're going to do is we need to first simplify that 18x to the 5th. So 18x to the 5th. So 18 I can break down into being 9 and 2, and then I can break that down to 3 and 3. So underneath the radical for 18x to the 5th, I end up getting 2 times 3 times 3, and then 1, 2, 3, 4, 5 x's. So I have one pair of 3's and 1, 2 pairs of x's. So let's go ahead and let's write that out. So I'm going to have the square root of 7 on top. Then out from my radical is going to do 3 times x, which is going to be 3x squared. And left underneath the radical is 2x. So to rationalize that denominator, I'm going to multiply by 2x over 2x. So 7 times 2x is 14x. Divided by, on the outside, we're going to have 3x squared, and then we're going to have 2x times 2x. So again, because I have two 2's and two x's, they both can come out of the radical. So I get the square root of 14x divided by 3x squared times 2x. So I get the square root of 14x, and then 3 times 2 is 6. X squared times x to the first is going to give me x cubed. So that right there is your final answer for number 12. Last but not least, let's take a look at number 13. So a period of a pendulum is required to make one complete swing back and forth. The formula is P is equal to 2 pi times L over 32, where L is the length of the pendulum. If the pendulum clock is 6 feet long, find the period. So I'm going to have the pendulum is going to be equal to 2 pi times the square root of 6 divided by 32. Now before I go rationalizing the denominator, I noticed that 6 and 32 are both divisible by 2. So I'm going to go ahead and I'm going to reduce that fraction to start off with. So 6 divided by 2 is 3. 32 divided by 2 is 16. This could potentially work out very well for me. So I'm going to go ahead and split my radicals. I'm just going to keep my 2 pi kind of just hanging out there. And then I'm going to do the square root of 3 divided by the square root of 16. Well, this is good news to me, right? Because the square root of 16 is a rational number, so I'm not even going to have to rationalize the denominator. I end up getting the square root of 3, and now I'm just going to put that 2 pi on top. Because when that 2 pi is being multiplied, it's really like it being in the numerator. The square root of 16 then is 4. Okay, so now what I want to do is I just want to reduce that 2 divided by 4, which is the same as 1/2. So then I'm going to get pi times the square root of 3, and then that's going to be over 2, because when you reduce the fraction 2 divided by 4, you get pi over, or you get 1/2. And then the L is the length in feet, so I want to make sure I label it feet. So that concludes your note video for today. Please make sure you get that Schoology quiz taken. Thank you for listening.